Welcome to Brain Vision.
In this problem, we have a rope with a given mass per unit length draped off the edge of the table. We want to calculate the velocity of its end A for any position Y as the rope uncoils and begins to fall. So if we apply our flow equations and we'll take the downward direction as positive, we know that the sum of the forces acting on the rope must equal to m times the rate of change of velocity of the rope m dv dt plus v di times the rate of change of mass flow dmi dt. Now at a given time t, the mass m is equal to the mass per unit length times the vertical distance y, the distance that the rope has fallen. And similarly, dmi dt is equal to m prime dy dt, and this is equal to m prime v. The rate at which the y coordinate is changing is simply v, so that's m prime times v. Now here v di is equal to v, the speed at which the rope is falling, and dv dt, the acceleration of the rope, is simply due to gravity g. So if we go back to our flow equation and we substitute our values in, we can see that m prime times g times y is equal to m prime y dv dt plus v into m prime v, and we're left with a differential equation. So if we divide through by m prime, we are left with gy is equal to y dv dt plus v squared. Now remember, v is dy dt, so dt is dy over v. So we can rewrite this as gy is equal to v times y dv dy plus v squared. So now we can write this as the change in v with the change in position y. So if we take this equation and multiply both sides by 2y dy, we get 2g y squared dy is equal to 2v y squared dv plus 2y v squared dy. And now we can integrate both sides of this equation. So the integral of 2g y squared dy is equal to the integral of the v squared y squared. And so that simplifies quite nicely, and we get that if we perform the integral, 2gy cubed plus some constant of integration c is equal to v squared y squared. Now remember, v is equal to 0 and y is equal to h. So if we plug h into this equation, we get that 2/3 g h cubed plus c must equal to 0. And therefore, c, the constant of integration, is actually minus 2/3 g h cubed. And so going back to our equation, we get that 2/3 g y cubed minus 2/3 g h cubed is equal to v squared y squared. So if we divide through by y squared and then take the square root, we get the velocity of the rope as it falls as a function of position, v, to be the square root of 2/3 times g into y cubed minus h cubed over y squared.